Welcome to Cultivating Success, Canada's big biomanufacturing opportunity, our latest CFIN Live experience. I'm Dana McCauley, CEO at the Canadian Food Innovation Network. At CFIN, we champion innovation in the food industry and take pride in being the go-to source for Canada's food industry innovators who want to keep up with trends, science, and the latest technology. Today, we're going to demystify the emerging biomanufacturing industry so that everyone can make decisions more easily about whether to join this movement as a producer, a supplier, or a consumer. To help us untangle all the language and the science, we've invited two of the world's leading authorities on the topic, Dr. Lenore Newman and Dr. Evan Fraser, to lead you through our CFIN virtual experience. Not only are they co-authors of the popular book Dinner on Mars, in autumn 2023, this dynamic duo will publish the world's first textbook on the subject of cellular agriculture and food. So without further ado, I'll turn the show over to Evan and Lenore, who are not only figuratively out of this world, but literally as well. Over to Mars.
Thank you, Dana. Whew. Evan and I have made it to the red planet, and I gotta say, it looks like it's gonna be really tough here for farmers. So we're gonna need a little bit of technology, things like cellular food.
Yeah, it's going to be a while before we get the all-you-can-eat smorgasbord up here on the red planet. So Lenore, unpack this for us. What exactly is this thing we're calling cellular food?
Well, Evan, I'll tell you what it's not. It's not magic, it's not mad science, and it's not just about meat. It's a whole new way of creating food ingredients.
Yeah, so depending on who you ask, it feels a little bit like fiction. It certainly feels like it's in the future. To many people, the idea of growing food in a laboratory is quite controversial. I think it's going to end up being very convenient. And at the root of all of these debates, I think cellular food is all about the potential to produce food in a new way.
Cellular agriculture and food creation is about the emerging field of creating products that are typically animal products without animals. But that's easy to say, it's really difficult to do. And we can do it a few ways.
All right, so break this down a little bit for us. Can you give us the difference between what people call cell culturing and precision fermentation? Because I've heard those words a lot, and maybe you can explain them for us.
Yeah, it's a great question, Evan. And a lot of talk about cellular food is about cell culture, where we take a sample from a live animal and we grow it in the lab to create a meat product. And then there's also, however, precision fermentation, where we take yeast or bacteria or fungi and we alter them to produce other compounds than the usual alcohol, although alcohol is great too. We produce things like proteins or other food ingredients. And in a way, that technology is further advanced, but we don't hear as much about it. People don't realize that the animal industry is a bit like an iceberg, in that we tend to see the cheese and the meat that we eat on our table, but a lot of products actually go into manufacturing, things like milk proteins. And we can actually brew those like beer or grow them in a lab, and we can still have that fancy cheese on the plate, but greatly reduce the environmental footprint. So yeah, we're going to be seeing chefs work with new products that aren't even available. We're seeing business-to-business plays emerging. We have hundreds of millions of dollars of venture capital going into the sector. So moving very fast. And we're seeing regulatory bodies start to struggle with the questions raised by these foods.
So I got two more questions, and they're kind of related. First, what's the potential for this in terms of food? Where are consumers going to actually eat this stuff? And when? When is this going to actually appear on the market?
Well, one of the exciting things, consumers are already eating these products and have been for, well, several decades now, because when we make cheese, we need a catalyst that we call rennet traditionally. Chemically, it's a substance called chymosin. And we couldn't produce enough of that to make as much cheese as the world wanted. So instead, we take fungus and bacteria that has been altered to produce rennet. And so we actually produce it using precision fermentation. And when you go to a store and buy cheese and it has vegetable rennet in it, you're eating cellular food already. And we're also seeing other products emerging. We're seeing in the US, you can walk into a store and buy ice cream that is labeled as non-animal dairy, which just, blows my mind. And if you go to Singapore, you can sit down to a meal of chicken that never went cluck.
All right, so tremendous potential, tremendous opportunity, tremendous disruption. What are the barriers? What are the barriers and obstacles that are going to prevent this brave new world from unfolding the way you've just described?
Well, I think the biggest barriers, this is a literal moonshot, or maybe I should say a Mars shot. It's going to take thousands of scientists to engineer this system. And part of that is about scale. And we forget sometimes that we've had 10,000 years to build the animal system, and it's huge. We have to make this as big as the existing food system, and that's a $2 trillion market for meat and dairy right now. And also, because food is very tightly regulated for safety reasons, and that's a really good thing, regulators need to get their head around entire new categories of food that are nothing like what we've done before. So I think there's a lot we need to do yet, but it's pretty exciting stuff. I'd like to hear from the audience. Tell us, if you were given the opportunity, would you try cellular food today?
For most Canadians, the concept of cellular food feels really quite new. But in fact, it's been in the works for decades, as you can see here. It all started in the 1980s when insulin was created using precision fermentation. In the 1990s, and in terms of food, vegetable rennet, which is a key ingredient in producing cheese, became the first cellular food product for consumption. In 2013, the first cellular-grown hamburger was eaten live on TV, grown by Mark Post and cooked by chef Richard McGowan. In 2020, Upside Food received the first regulatory approval for any cultivated meat product in the US. And up here in Canada in the 2020s, Cult Foods, New Harvest, and the University of Alberta created the Institute of Cellular Agriculture.
Wow, Evan, I can't believe how much has happened in such a short time. How much did that original Mark Post burger cost anyway?
So when we go back to 2013, it strikes me as amazing, but the original Mark Post hamburger that was grilled and eaten on live TV cost in excess of $300,000. But today, that same burger apparently can be produced for approximately $10.
That's incredible in only a decade. So I think we can safely say this isn't just space age science fiction stuff. This is really happening in labs all across the country, all around the world. So I want to know more. Let's head over to the CFIN lab to carry on the conversation. And where did we leave that rocket? Oh, that's a long trip.
All right, so Lenore, we've gone over the what around cellular agriculture. Now let's talk about how we're actually going to do it. It's probably easiest to come at this by imagining a single product. So let's use the common burger as our example. What do you think?
There's a lot of steps that go into that process. We are going to have to go and find a cow that we really like. We're going to scritch it on its little head, and we're going to take a cell sample, and it won't bother the cow at all. And then we're going to take that cell sample back to the lab.
All right, so you've got the cells from the little scritch on the head. We call that a biopsy. Take those cells back to the lab. Take us through the next steps.
Yeah, and there's a few paths we can follow from there. First of all, we're going to take those cells and we're going to put them into a bath of what we call serum. And serum is like a nutrient liquid that helps them grow. And we're going to do that in a bioreactor, which is a container that holds our cells and our serum. Now, cells naturally will only divide about 50 times. That's kind of their lifespan, which doesn't sound like a lot, but they're doubling every time. So that might be good enough. It depends how much we want to get out of this one sample. The alternative, if we decide we want more doublings than that, we do a process called immortalization. And we change the cell so that it never dies, so that it's immortal, and it will just double forever. So we now have our cell. We put it into a bioreactor and we add growth serum. And that then grows our meat cells.
All right, so far so gross sounding, to be honest. That does not sound like food. That sounds like a bunch of goop in a lab. What comes next?
Yeah, the technical word is slurry. And no, we don't want to be marketing slurry. So how do we take slurry and turn it into something? Well, there's a few steps. So number one, we have to give the cells form. There's a couple of ways we can do that. So we use what's called a matrix or a scaffold. And so that could be made out of plant-based material or could be grown. And we shock the cells into growing on the scaffold like they would on an animal bone. And that'll give them form. Or we can use a 3D printer to print them into layers. Now, cells on their own aren't that tasty. I mean, it'd be nutritious, but it's really lean at this point. So we want to add some fat. We can do it the exact same way. We can take a cell sample and cultivate fat cells. Or we could use precision fermentation to make an animal fat. Or we might decide just to use a plant fat.
Like palm oil or sunflower oil or something like that.
Exactly, coconut oil. We've got a big range. And then we'll mix in a bit of flavor and color as well. Might use other products that like glutamates that pump up the flavor, things that really make the final product look the way it should. And that's basically the story. Now, it was pretty easy to describe. It's a lot harder to do, but that's basically it.
The potential of this approach, I think, is that it'll give us the ability to create what probably will be biologically and nutritionally very equivalent products to what we're currently consuming, but we'll do it using new methods. And one of the reasons I get really excited about this is that along the way, along this pathway, I think we'll even find some truly new foods, things that we haven't even imagined yet, the likes of which we have never probably even seen.
It's so true. We're using these innovations for so much more than meat. Using it for leather, for silk, for all of these animal products that surround us. Even extinct foods. There's a company working on mastodon cells. Wow. And so we could have a mastodon burger instead of a beef burger. So that's Back to the Future right there.
According to a recent Royal Bank of Canada report, between 2018 and 2022, $91 million were invested into Canadian firms working on cellular agriculture. Does that seem like a lot to you?
Well, it sounds like a lot, but I guess it really isn't when we compare it to global investments of $7 billion.
Yeah, I agree. One of the things we're hearing a lot in the community is that more investment is needed to help companies scale up, cope with the high upfront costs, get to a commercially viable operation. We have so many early stage innovation opportunities, entrepreneurs that really need the investment to prove their value and also critically to maintain Canada's sort of competitive advantage on a very, very challenging global scale. So let's go. Let's go and meet 4 of the great entrepreneurs that are starting up cell ag companies in Canada today.
So we're here with Dr. Fay Lois from Liven. And Fay, it is so good to see you and to see what you've been up to. So can you tell us a bit about what Liven has been doing and how it differs from the traditional animal counterpart?
Absolutely, happy to share. So at Liven, we make collagen, but animal-free. So we can create this very versatile ingredient using the technology precision fermentation. So functionality-wise, it is identical as animal-based collagen. So it is very versatile. It can go to the bone broth, for example, to nourish you.
Faye, this is amazing to me. What are the main selling points of your product? How do you communicate the benefits of your collagen to your consumers?
Yes, our customers are very excited about our product because number one, our collagen is very soluble and you can add it to your morning routine, for example, in your favorite drink. And it creates this colorless drink that you can enjoy without any off odor and also the taste. In addition, because it is animal-free, so you don't need to worry about the kosher, halal restrictions. And if you're worried about a marine allergy, you cannot take marine collagen, and there's no problem to use our products as well.
Nice.
Well, Fay, this is amazing. I mean, I've been waiting for a boneless gummy bear for so long, and here you are. So I got to ask, what does Liven need to achieve its mission?
In order to bring this innovation to really disrupt the supply chain, we need to achieve the massive scale because our customers are food and beverage manufacturers and they really need sustainable supplies of our products. And in order to achieve that scale, we will need facilities and talents and very importantly, capitals as well.
So Faye, you've talked about the needing for talent, the need for capital, the need for better facilities. There's probably some regulatory things you also need. If you were going to wave a magic wand and reduce one of those barriers, what would be the biggest enabler to allow you to go to scale?
Right now, I will say capital, because capital will allow us to create larger scale of production and also hire top talents from the university to join our team.
Faith, thank you so much. And I think we're going to be seeing a lot of Livent in the future.
Thank you for having me.
So, having talked with a number of food innovators, we're going to meet another one, Pratish Gawande, who's the CEO of Ardra. Hi, Pratish.
Hi, Evan.
So, you're one of the first precision fermentation companies in Canada, and you're using this amazing technology to bring about that golden age of food. So you have to explain what we're standing next to and tell us a little bit about Ardra.
Yeah, thank you so much. Yes, we are one of the first precision fermentation companies in Canada, and what we are using precision fermentation for is to make high-value food ingredients. We make ingredients such as flavors, they can be colors, they can be nutritional ingredients. And what you see here is a 2-liter fermenter in which we are currently brewing heme. This is our lab scale fermenter, and we have actually outgrown Canada, and we are running our processes at 5,000 liter fermenters. So yeah, we are using precision fermentation to bring a lot of novel food ingredients into Canadian food value chain.
All right, so this is 2-liter, but really you're doing it on a 5,000 liter scale out of Canada. That is truly amazing. So, but I think we need to take a quick step back, and maybe you can tell us a little bit more about this product heme, because we keep hearing about it, we keep reading about it, I keep talking about it. Explain what heme is, and what implications does your heme have for the culinary world?
So heme is a natural product. It's present in blood. It's part of hemoglobin. That's how we know heme. Interestingly, heme is also responsible for meaty taste of meat products. Now, plant-based food formulations don't have heme in them because plants don't make blood. They don't have blood. So the flavor aspect, the color aspect from plant-based foods is missing. And what we are doing is we are making heme by fermenting sugars using precision fermentation, and that gives plant-based food formulators an ingredient to add to their formulations to make their formulation taste real meaty and to even bleed like meat.
I know that Ardra produces more than just heme, so maybe talk about what other things Ardra is working on, and then also reflect maybe on what the sustainability implications of your approach might be for the world at large.
Yeah, so sustainability is the main mission of Ardra. We want to make our food value chain more sustainable, and heme is one of our products, but we also work on other different products that are typically made from botanicals, the flavors that are extracted from botanicals. We all think that natural products necessarily make food industry sustainable, but that's not true. Think about palm oil, how it is causing deforestation. So what we do is we make all these ingredients, natural ingredients, using fermentation, precision fermentation, and we make it more sustainably from sugar. And we're also making these ingredients locally, so making the supply chain, the local supply chain more strong. By introducing novel ingredients like heme, what we are doing is we are enabling the plant-based food companies to make their products more consumer-friendly and thereby helping to make the food value chain more sustainable.
Yeah, so I'm hearing two big sort of major take-home points. Take-home point number one is that you're providing a really important ingredient into the food industry, contributing to that golden age of food science. Take-home point number two, you're shortening supply chains, bringing things more local, and increasing a country like Canada's food sovereignty. That means that we're going to be more resilient in the face of global shocks and disruptions.
That's true, and we have to invest in this technology because it is important for our future sustainability.
So Pratish from Ardra, thank you so much for joining us.
Thank you so much for having me here, Evan.
So I'm here and I'm kind of wondering what came first, the chicken nugget or the egg. And I'm just so excited to be here with Han and Gobi from Yex. And they work in the serum part of the cell food chain, which we discussed a bit earlier. And serum's a bit of a roadblock because it's expensive, it's really hard to do at scale. So how did you get the idea to use eggs to produce serum?
So by trade, I'm a cancer researcher, and at the University of Toronto and at Sunnybrook Research Institute, we use chicken embryos to grow patient tumors. And the reason why we do this is out of the calling for precision oncology, where we're trying to improve decision making for cancer patients. And one of the things that I realized is when we were growing these patient tumors to figure out what drug we should offer the patient, I began to realize that, wow, these embryos, there's no blood in them. They're mostly living off the yolk. The yolk is sustaining them. And so that really got me thinking, could this also have applications for culturing cells? And so that's when Gobi and I started working together to realize that there are certain parts of the yolk where we just pull out and reduce it to this liquid media that we have over here. And when we use it to grow cells, it works fantastically.
You know, it's amazing. It's such this light bulb moment, it feels like. But why did it strike you as so important to do this?
Well, an interesting story is when you know, Han and I started talking about it, I to be completely honest with you, I didn't believe it until I started testing it. And when I saw these cells really grow, even faster than, you know, fetal bovine serum, which is the current standard for growing cells, I was really, really happy and really excited. I texted him almost instantly, and I knew this was going somewhere. And when we started making it, we also started testing it on food cells, cells that will eventually become lab-grown meat. And so when we did that, these cells also loved our serum. Normally, we would have to use something like fetal bovine serum, which is really expensive. It costs anywhere from $400 to $1,000 a bottle. But ours is at a fraction of the cost, has the same potency. And we use eggs to mechanically source all the nutrients out of it. So what we do is we take the serum and we grow the cells. And the cells, actually, we have a sample here, eventually become a pellet like this. And so when we mix this pellet with some additional ingredients, we can get something like a nugget.
Wow, I mean, it's so amazing and clearly a big step forward for the industry. But also, I've heard there's big sustainability benefits to this approach.
Yeah, so thinking about our competitors, they're also trying to do the same thing. But their call to fame right now is using plant-based chemicals to help these cells grow, whether it be chicken nugget cells or even things like things that make foie gras. And the main difference for us is that it's low cost, but it's natural. We're not using solvents to pull out those plant chemicals that then go on to be used for culturing the cells. We actually bypass all that. The eggs are coming from layer hens, and they're coming from a hatchery. And in terms of sustainability, this is a product that is a serum replacement, but it's slaughter-free. So we're basically procuring the eggs and then going into the lab, into the manufacturing plant, and converting the yolk into what you see in front of us. And then another sustainability thing is we're already kind of fit for scale. There's so many egg hatcheries that are out there, and we can just access that large pool of suppliers in order to create this product, which we call Yak Serum, and make that available to many other companies that want to do this as well.
Thanks again, Han and Gobi. So amazing to see what you guys are doing. And this has just been some incredible technologies. But if you think you've seen it all, we're going to take you to Evolve Meats in Ontario to see how they're innovating in the space of cellular food.
Hi, I'm Ali Reza, one of the co-founders of Evolve Meats.
And hi, my name is John. I'm the other co-founder of Evolve Meats. We're here today at our headquarters in Kitchener at the University of Waterloo's Velocity Incubator.
At Evolve Meats, we are making cultivated meat from different species. And we are different from everybody else in the fact that we are making a product that is exactly identical to meat, to the meat that you are getting from the animals, down to the molecular level. Unlike others that grow stem cells and mix them with plant proteins to extrude them or put them on scaffolds or bioprint them to make a product that looks like meat and feels like meat but is not exactly the meat that we know and love. We have processes that are adapted from tissue engineering that take those cells and allow them to make the muscle tissue itself, and eventually that muscle tissue transitions to meat in a way that makes a product that is exactly identical to conventional meat down to the molecular level.
Ali and I met at the end of 2020. I was the director here at Velocity, and Ali had applied for funding, seed funding, to actually start his company. By fluke that same month, Nature and MIT Tech Review all had articles on cultivated meat and how it couldn't work, so it gave me a great set of questions to ask him when we met. I was incredibly blown away by what he was doing and the answers he gave. So we not only decided to invest, but we connected him to other investors, and in that process I ended up joining the company. I was lucky he took me. It became clear to me that not only was this something that we should be doing, but this is something that we should be dedicating ourselves to because of the massive impact we can actually make, not just for Canada and for food security and for food scarcity issues, but globally for climate.
So we are tissue engineers, and tissue engineering has been limited to the lab for the past few decades. We have made little progress when it comes to recreating tissues for implanting them inside the human body. Now we are using the same techniques for very different reasons or for very different purposes. We are trying to mass produce a meat product that needs to be exactly identical to the conventional meat, and that's how difficult this task is going to be for us. And there were a lot of people that were skeptics of this whole process, but we developed new processes and new techniques that were specifically designed for this application and solved many of the problems that we thought we couldn't solve. What you are looking at here is the automation piece that we have for making cultivated meat at scale in an automated way, which becomes really important when we want to mass produce cultivated meat and replace a meaningful amount of meat that is currently being consumed using cultivated meat. So the device that we have here is built by the collaboration with one of our partners. They have been working in pharmaceutical industry, they have a lot of experience, and they helped us de-risk the whole process and make this device a lot faster than we could do in any other way. This is a first of its kind, and let me show you what it does and how it does it. A piece of our technology is made out of these proprietary membranes that are used for growing and differentiating stem cells and turning them into the components of cultivated meat, including muscle fibers, fat cells, as well as the connective tissue that naturally exists inside the body. What happens is that inside an incubator, which is what recreates the environment of the animal body, we grow the cells and turn them into something like a sheet, exactly like a sheet of paper on these membranes. And this piece of robot is going to turn these sheets into fibers that then can be stacked and turned into a structured meat, something that is exactly identical to what you get from the animal. It doesn't have anything that you can't naturally see inside the animal body and the muscle tissue or the meat that you consume. So once the robot is done with what it's doing, all of the cells and the proteins that they have secreted on these membranes turn into strands of either muscle or fat, and we can stack them to create the fibrous meat. This process that has always been done manually with the operator in the lab now can be done at scale in automated way and outside the lab in a food production facility. So the future of this field is going to involve a lot of these robots, all of these arms that are working really fast in parallel with each other, and lots of meat is being produced in a matter of seconds or minutes, as compared to when in the animal body it takes months or years to make the meat that we need. This process is not going to have any harmful effects on the environment, and the product that we are going to have could be even healthier. We need to make sure that the food that we are delivering to people is going to be safe. And we have to run lots and lots of experiments to make sure that when it comes to the nutritional values, it's exactly identical to meat. And we believe the process that we have created is exactly identical to what happens inside the animal body, and therefore the product is going to be the same as well. But obviously there are many experiments that need to be done before we can actually have these products safe and delivered to the consumers.
So the first major challenge is, can we grow enough cells to actually make this viable and actually use those cells as the final product? Second, when you think of the pharmaceutical world, they always created very little amounts of product at a very high cost, and we're trying to flip that equation. We're trying to create a lot of product at very little cost, and that obviously requires not just innovation on the scientific side, but also on the engineering side. And that's something that we've been making steady progress, not just us, but everyone across the industry. Third, I think there's going to be a consumer adoption issue because this is such a different idea, and something you put in your body has to be so intimate. So one of the things we really appreciate here, and one of the things we point to is 10 years ago, you wouldn't have gotten in a stranger's car or slept in a stranger's house. And here we are 10 years later calling Ubers and booking Airbnbs. So we think as long as we can properly educate consumers and actually take the right steps from our end to be transparent, we can really drive that market adoption to help make that huge change in the food system. For us, our primary customer is going to be other cultivated meat companies. So when you look at cultivated meat, there's two big problems. One is growing enough cells, and the second part is differentiating those cells and actually forming them into the meat we're all familiar with and we love. So everyone else in the industry is kind of working on that first step. So we work with groups that are already growing enough cells. We then take their cells with our proprietary process and actually differentiate the cells into a final product and assemble it into something that'd be familiar and loved by them. So in terms of our next steps, we're actually signing a joint development agreement with one of the biggest cultivated meat companies in the world right now. We're going to be working together to recreate a piece of pork belly that's going to be identical to conventional pork belly over the next couple of years. In addition to that, we're working with a couple of different US partners to be able to scale out our ability to make our muscle fibers. And we expect that to be done also over the next couple of years. Within 5 years, we think we're going to be the only group in the world that's able to fully recreate meat that is identical to conventional meat. If we had one wish on what could help us accelerate and kind of compete on a global stage, what we really need is the Government of Canada to step behind biomanufacturing and properly support companies that are driving innovation in this field so that we're not always forced to look outside of the country to keep developing and growing our operations. Thank you very much for joining us today and learning a little bit more about what we do. Obviously, we're incredibly thankful for CFIN for this opportunity and to see other companies that are being supported throughout the Canadian ecosystem. We're excited to learn more about what everyone's up to, and we hope to join you at a dinner plate near you soon enough.
Dr. Yadira Tejeda Saldana from New Harvest. Welcome.
Thank you so much for the invite. I'm really excited to be here with both of you.
We're so excited to be here with you. Yadira, we really admire what you do. Can you tell us a little bit about New Harvest?
Well, New Harvest was the first nonprofit organization that started supporting cellular agriculture. Our mission is to advance cellular agriculture and also maximize a positive impact. So really thinking about a food system that is just, equitable, and sustainable. And we do this by conducting and supporting original and open research. And we also support a lot of collaborative initiatives and multi-stakeholder engagement.
Yeah, and as one of the collaborators for many years with you, it's been a real pleasure and a joy to work with you. You're at the pioneering edge of this emerging new field, so you're a really good person to ask the question, why should Canadians care? What benefit does cellular agriculture offer to Canada?
That's a pretty good question, and I would say that cellular agriculture can bring a lot of benefits to Canada. Let's just think about the crops that we produce here. Canada is one of the biggest crop producers in the world, but what do we do with them? We send them to other countries to be processed, and then we buy again the added value products instead of actually processing them here and producing those added value products that can bring more benefits to Canadian economy.
Yeah, the way I look at it is that sort of the ways that we've used to grow food over the last 50 or 60 years involving long distance trade and things like that, they're not working as well as they should have been. And the 3 C's of COVID and conflicts like in the Ukraine and of course climate change mean that food is more expensive. Climate change isn't only changing our growing seasons, but is also changing where crops produce. And agriculture and food systems globally are responsible for about 1/3 of the world's greenhouse gas emissions. So for me, we need new ways of doing things, and one of the key strategies of that is cellular agriculture. And maybe cellular agriculture can help us bring our greenhouse gas emissions down while addressing food security.
Well, and that's so critical. We know that we need to get the food system to a net zero state where it's not making the problems worse. Yadira, what do you see in the way of mitigation that you think cellular food can bring to climate?
Yeah, well, one of the biggest benefits of cellular agriculture is actually helping us mitigate climate change. We can actually produce food with less greenhouse gas emissions, and we can also produce the food locally. So we will be really independent of the climate change. It can also help us, for example, reduce the amount of land, the amount of water, and also the amount of eutrophic issues that we can have with current agricultural systems.
Yeah, so from like disease to war to unprecedented weather patterns, I really think there's cracks opening up in the global food system, and maybe you can help us reflect a little bit from your work with New Harvest on how maybe CellAg can address national and global food systems and food resilience security needs.
Yeah, that's a pretty important question, and let's think about COVID. So during the COVID pandemic, Canada wasn't really prepared for it. We needed to actually depend on PPE and vaccines that were produced in other countries and then buy them to actually respond to this crisis that we were facing. So cellular agriculture can actually help us have local production of food if we have the right infrastructure, if we have the right supporting systems to actually do it. We can create a system that is not going to be dependent on climate, and we can actually fight food insecurity here in Canada. So I think there's a lot of opportunities for Canada to be a leader in this new and emerging food technology.
Yeah, I totally agree. I also think it's important to note that Canada, for instance, as a country, is not only protein self-sufficient right now, we also export a lot of protein. We also know that the world needs more protein, and we need to do that in a way that doesn't contribute to climate change. So this is not an either-or proposition, it's a yes and we need all these things. And Lenore, you sometimes talk about the need for a portfolio of protein sources. What do you think about all that?
Yes, and we tend to think about protein as coming from animal products, and of course it does. But we have a portfolio of tools for producing proteins for the food system. So we have plant-based proteins, which of course are one of Canada's big exports and one of our strengths. And we have animal-based proteins, but we know we need to do them a little differently. We should be looking at regenerative agriculture, at more grazing. So how do we make up the difference? Maybe cellular agriculture is a big piece of that. It's a new tool in our portfolio to make sure that we have enough protein for the entire planet.
Yeah, and not to mention that it is actually a massive opportunity for a Canadian economy.
Well, and it's no secret that cellular agriculture is either going to happen in Canada or to Canada. So what does the industry need for Canada to be a real leader in this field?
Well, I think there's a lot of things that we need to think about to build the right infrastructure for cellular agriculture to happen in Canada. Let's think about the talent. Let's think about the facilities where actually entrepreneurs can do their experiments, scaling of facilities. So there's a lot of things that we need to think, and we need to start developing them right now so that we are prepared for the future challenges that we're going to be facing.
Maybe CellFood can even help with the price of coffee, because it's pretty steep these days.
But that's sort of the point. Like, it's an illustration. This is the third year in a row that demand for coffee has outpaced supply. Globally, our supply of coffee is actually supposed to be 3.8 million bags short this year, and that, thanks to climate change, isn't going to get any better.
Yeah, and let's not think only about coffee. We can produce also vanilla or chocolate with cellular agriculture.
Well, that's a cup half full, really, and we're uniquely positioned to provide that solution, and I'd argue Canada has a secret ingredient that most countries don't.
Yeah, I think we have to remember as a country that we have a lot of natural advantages in this space. We've got everything that we can imagine. We've got that supply of talent you just talked about. We've got gutsy entrepreneurs. We've got a stable market, a good regulatory environment, and critically, we've got biomass, the stuff, the plant material that needs to go into the bioreactors to let these cells, whether it comes from tissue culturing or fermentation, let these cells grow. What do you think, Yadira?
Well, we have a lot of byproducts that come up from the processing of proteins, for example, and starches. Let's think about starches. They can actually produce or help us manufacture the sugars that we need to feed the bacteria or to feed the cells that are going to grow in the bioreactors.
Well, and maybe these starches actually give us the potential to compete on price with other places in the world because we've got the feedstock.
Yeah, let's take a step back though. Let's realize that This is building on one of the great Canadian farming success stories. And our farms on the prairies produce some of the most efficient, highest quality plant protein anywhere in the world. Now, some of that is lentils. Export most of those lentils to places like India. But I think a crop like a pea, that's actually a product that's used as an ingredient by food manufacturers. And what happens is that pea's taken and you fractionate out the protein. And that leaves that high quality starch that you're talking about there. And really, I think it's possible to imagine that this byproduct, this starch product that doesn't have a tremendous amount of economic value right now, could be used in a sort of a way of channeling the circular economy by entrepreneurs funded by New Harvest that would ferment that starch into higher value products. What do you think here, Lenore?
Oh yeah, and I mean the sheer volume of starch we produce, I could imagine us exporting the starch and countries like Singapore fueling their bioreactors to make chicken nuggets using Canadian starch, and that's a real win for our economy. I just realized we've been using the term bioreactor a lot. Maybe we need to take a minute and talk about what they are and what they do.
The Visuren Centre is a not-for-profit organization focused on commercializing clean technology solutions for the world's biggest problems. So bioreactors work by growing the microbes, whether those be microbes, yeast, algae, whatever source it is that a client has, in a medium which supplies them nutrients, which is liquid, and ferments those at certain temperatures, oxygen and pH, which are desirable to produce the value molecules the client's looking for. That's how a bioreactor works. So they're using our bioreactors to scale their process and optimize their process. So typically they come in and they've only run maybe a 250 ml flask version, where we have a 5 and a 10 and then a 100 and 1,000 liter reactor vessels. They're using those vessels to scale their process and optimize it. Currently, our capacity is continually expanding, so we forever hit capacity and then we grow. So to continue to support more clients, we need to continue our expansion of our physical capacity, which is the bioreactors, but we also support clients with all kinds of other funds and HQP and those things, and we count on partners in our ecosystem to continue that support for clients. So currently for Cell Ag and for any other biomanufacturing, there are very limited capacity on the market right now. And typically clients are having to go to the US to find this capacity, which is the main reason we've built what we have built. So right now, Canada and the universities in Canada have spent many years generating companies that have these technologies with synthetic biology technology that are producing all the value molecules we need. What we haven't built in Canada is the scale-up capacity. And that's why in Canada we will be behind the US if we do not build scale-up capacity. And that's what's driven us to do that. The thing that I would add is just the magnitude of the impact and the variety of products that these clients produce. That number one, there's a big pipeline of companies that are going to need this capacity. And number two, from the pull side in Canada, our manufacturing are going to need these green ingredients and chemicals for our own supply chain. So in terms of competitiveness for Canada, it's critical that we build this infrastructure. I think from the Visuren Centre perspective, every client that comes in the door is really exciting because there's just such an amazing array of products in our everyday lives that we're helping those companies produce. So in terms of the Visuren Centre, I'm excited about our ongoing growth. I'm excited about our 10,000 litre commissioning coming this summer and excited for more clients to come here and take advantage of it.
Well, Evan, we've certainly talked to a lot of interesting people today.
Indeed, Lenore. I'm really glad we've had the opportunity to pull back the curtain, so to speak.
Well, and you and I have been doing this for a while, and we've seen so much change in the industry in a short time, and it's speeding up exponentially. Do you remember it was less than a year ago. We were in the Bay Area. We were checking out Perfect Day's famous ice cream and seeing plant-based burgers that had cow cells grown through them.
But you know, the real highlight of that trip has to have been the salmon we ate. The salmon we ate. Now, I bet the average person, if they were to eat that salmon in a sushi roll or a poke bowl, I bet they wouldn't be able to tell the difference between a traditional salmon and that cellular salmon that we ate when we visited Wild Type's facility in California. But hey, you don't have to take it from me. Let's check with the audience. Tell us in the comments, folks, which salmon do you think used to swim?
Is it A or B? You know, Evan, all this talk about food has got me pretty hungry. Do you want to go grab a bite?
Always.
Awesome.
Thank you, Lenore and Evan, for breaking down this complex new food production method for us. You have opened our eyes to a promising opportunity for Canada. And thank you for watching the CFIN Live experience. We hope you've learned a lot and are feeling as excited about the future of food as we are. If you're still hungry for food and innovation inspiration, though, head over to Yodel, our innovation connector platform, to explore more content. Yodel's a first-of-its-kind meeting place for everyone working in the Canadian food ecosystem. Not only do we have more videos about cellular food on our platform, but there are articles, infographics, and discussions taking place there that will deepen your knowledge on this topic and many others, including automation and robotics, plastics reduction, artificial intelligence and machine learning, and so much more. You'll also find information on Yodel about our funding programs, which offer support for innovation projects that will transform and accelerate success in the food sector. Becoming a Yodel member is free, so sign up today. And once again, thank you for joining us for this CFIN Live experience.
What?